Hello there again. It's me again. Well, let me just give you some of the comedy of my life. So I went. That thing's still doing its thing, by the way. I think it started at 3 a.m. So now it's we're approaching 15 hours. 3 to 3 to 12. 3, 4, 5. It's 14. Yeah, almost 15 hours. I'm not done yet. Well, I don't want to do too much stuff with the computer because like the keyboard's getting hot and the fan's been going like crazy. It's not disk access; it's just the processor. This must be a highly processor-intensive operation. I don't know why. It's basically a copy. But anyway, I went and I just checked out the file directly with Windows Media Player Classic, my favorite video watching tool, and I found out that that the concert is not in part 2. It's in part 1. So that'll probably be another 8 days or so before I get to see that one. I'm getting starting to download now. It must be right about the end of part 1. Because I've seen part of the concert, and I know that it starts around dusk, like it's not nighttime yet, and it ends when it's nighttime. And this starts, it's nighttime here, but within this is a 4 hours segment, and it's all nighttime. So the part I want is probably right at the end of this. But no problem, I got a whole bunch of concerts I can watch when this. I could just watch them directly. I don't need to finish the conversion, but I might as well. Let it go for 15 hours. Might as well let it complete its thing. In the meantime, getting back to what I wanted to do with this notepad cube, I wanted to make that separate thread that does the that's a dialog box with a percentage bar. And that led me to doing a whole bunch of things that I know I needed to do, and I've needed to do for a long time, to do with other things. Like Notepad Cube uses this those system errors that you get from an error number. Somewhere in here. Here. Right? Now I figured that I might as well put that into a common area. It's a useful function that just returns you a string. Given an error number, returns you a string. Okay? Alright, no problem. Now previously, this thing just declared an array and called a special function which is supposed to be safe. That you can see what it used to look like. Here, this is the prescribed way to do it. Now, of course, what number do you put in here? Don't know. Right? It either works or it doesn't. I don't know what the longest number is. Now, I know it can't be very long, and I could just make up a number and it'll probably be fine. But there's another thing that you can call, or you wouldn't even need to know the length of this string, because it just gives you the string as a literal. And that's, ignore all that other stuff. That's this here. Ignore, I said. This here, it's really it's a function, but it's a function, and the function returns an array. Here's the declaration. It's a number defined, and then this is actually called a function, which I don't know why they call it car star star, but you can't modify this. It is for backwards compatibility. Okay. But that doesn't matter in my case. There's nothing unsafe about using it. But I think the unsafeness here is in the fact that it's just an array of strings, and you could pass in an offset that's too big or something like that, right? So what I want is to make sure that this error, if it's too big, I don't use this array, right? And turn an unsafe thing into a safe thing, and I don't even need to know the length of the string, and I don't have to guess, as long as I know what the maximum length of the error number is, right? I mean, I'm not worried now about the length of the strings, but I'm worried about the length of the array. Now, this thing is a global thing, and unfortunately, I don't see anything in here that tells you what the maximum value is. Maybe this is. Maybe you can call this. But I wanted to do this anyway because I've needed for a long time a way to safely do things that are not thread safe, right? Global one-off things that you want to do at a point in time when you know that it's safe to do it and nothing's going to access it. Okay, so one of the things is computing this number, and I know how to compute the number. You just get the list, right? Walk through, and as soon as you hit a value that wouldn't be a valid string, that is something, it's just a small number like 36 or something, then that's the last entry. And it turns out that the last entry, I thought it might be 0. That would have been easier. But the last entry contains the actual count of elements in the array. -1. It tells you what the maximum index is that you're allowed to use. Something people usually call the max extent, like that. Okay. Now, what this bit is about, why it's written this way, is because I invented a global number, and I set that number by walking through the array and then reading off, how many things I counted up, and setting that global variable. And it's done before main. Before main ever gets entered, right? Now, it's possible that somebody could have declared a type of special structure that during the Initterm part might have started another thread. That's possible. So it may not be thread safe even during Initterm, that is when initialization is occurring. And you have structs that are global. Their constructors get called, before main. So somebody, if they wanted to, might think, oh, this is a good time to start up my special thread. Okay, so now that would be terrible, because then anything I'm doing during Initterm is not necessarily thread safe. So I figure I need, first off, I want to be able to do this thing in Initterm, and I don't want to worry about threads, right? So what I need to do is I need to have a way of prohibiting the use of create thread until main gets entered. So once the program's started, then you can make all your threads do whatever you want. Before that, I want to disable that functionality. That means that what I need is to be able to do in common init, or in this function, this. This is my thing I just added. Well, first this is a function that I had to write. Now I'll show you how it works. This gets the current number of running threads. It returns a bool for success, if it succeeded or not, and you pass it a reference to an int, and that number's the number. That should be 1 because there's always one running thread, and that's the main thread of the process. However, if it's not equal to 1, then I'm just going to abort. So if anyone starts up a thread, of course they could start it quickly and let it die, but whatever, that would be pretty useless anyway. If somebody wants to start a thread up and running early on, that typically would be something that you'd want to keep running and have been running when everything else is starting up. No go. Disallowed. Now, I looked online and I found some code to do this. So I'm going to start here now just by explaining how that works. Let me see. My time. I'm not worried about the computer now with the heat because what I've done is I've raised it up and I've got the fan on, another fan blowing air underneath it so it won't overheat. I looked online. Oh wait, time. I went online and I found some very nice code to do this. I wonder if it's still on that web page. Here it is. The old new thing. There's this thing, and I'd forgotten about it too, called the tool help library. It's kind of like that debug help library, and it's got all kinds of really awesome little functions in it. One of the things you can do is create a snapshot of the current, not just your process, but all the processes in your memory arena, and you can walk through them and all of the threads and all of the processes and so on just by calling this create snapshot. Single function call, and it returns a type of handle value. You don't have to know how that works. And then, if you want to walk through all of the threads of all of the processes, you can do like this person has done here. This is whoever wrote this is someone that I like. They've written a very straightforward function, and even pointed out a really great little macro I never knew existed, but I've made my own version of this that is better named. Field offset is the offset within a struct of a particular member of that struct. Okay, so this is the idea. It's like a get first, get next type thing. So if get first succeeds, first you have to check. Apparently, even though this struct has a definite size, the size value returned in this struct after this call or this call might be smaller than the actual size of the struct. So it might not include this particular member. The struct itself has several members, not that many really. I've copied this almost exactly. Here's the struct. Okay, so there's the size, usage, whatever. Okay, I'm not interested in these things. Maybe another day I would be. But these two fields need to be. I need these two fields. Well, this one is further down than this one. So if we got this one, we got this one. Now, so going back here, if the offset of that particular member plus the size of that same particular member, if the size of the thing, I should say, is at least as big as the end, where this one would end, then we've got this is a valid member, and so is the other. And then it just prints out process and thread. Okay. And now this has to be refreshed every time. And you see the way that this person has written this correctly? Like this refreshing is being done right next to this call to show you how this is related. Maybe he hasn't done this or she hasn't done this on purpose, but that's good coding style too. Something like this, you see, could have been done somewhere else or whatever, and you might not have noticed it, right? Here, I didn't even notice it until I was looking at this line, and it's right at the context where it's relevant, and you can see that this is a refresh of this because it's being done here, and then again here. So you got to keep refreshing the size of the struct that you're passing in, and it in turn wipes that out and puts in whatever it gave you, and you go along just walking through the threads, no problem. Then it took me a little while to figure out, well, what I want to do is isolate the threads that are within my process, because that gives you everything. Maybe there's a better flag. Just snap threads of process or something. Here. I probably should have done this instead, snap process. But whatever, it's okay. I was interested to see, what I would get out of this. And a whole bunch of stuff comes out. And maybe I'll change that later, but for now, it's kind of interesting to go through them all. Okay, so now this is a Boolean function. If this fails, then return false. Now it takes a integer reference and optionally the address of a pointer value where you would put an array of thread IDs, okay, for this process. So this const here applies not to the entries of the array, but to the array itself. I'm not allowed to modify this number. And this number you could set to null, and then that's the default. You don't get anything. So this is quite simple now to do. Get first. If the array value is, if this argument is not null, then I allocate an array size times size of d word is stored as the value of that pointer. Okay, now I changed that macro to something that it reads better for me. If struct contains member, right? It still uses that field offset. So if the struct contains member, and here's the member, then if the owner process is equal to my process ID, to get your own process ID, you'd think, okay, get process ID, but that doesn't work. That gives you one of those pseudo handles, right? And get thread ID as well. It gives you a pseudo handle. If you want, one way to do it is like we did before. You could get it out of the thread information block, right? The hacky way. But I think this way is this is guaranteed to work, and there's no hack this is a thing that can convert a pseudo handle into at least an identifier. So to get your own process ID or any process ID given a thread handle, pseudo or not, this works. So if you really had a real thread handle from a thread that you created, this should work on that as well. It'll give you the process owning that thread. Well, I get my current thread and get the process owning the current thread, then that's my process. Okay. So now there's just a little malloking thing to deal with here. If the array count gets to, array size, then I gotta bump it up. Here I'm just multiplying the array size, doubling it, right? And then reallocate to new array size, right? And increment the count for every one of these in the thread. And I tried it, and it all works perfectly. I can now enumerate the threads in the process, and I can now put that assertion in common before main gets called. So I now have a window. There now exists in all of my programs a window wherein thread unsafe operations may be done safely. And that is during Initterm program startup, global things, for instance. That's why I have these weirdo globals, static globals and stuff. Setting those things as thread safe because it happens before main or anything ever gets entered, and there's no more than the one thread running at that time. Now that's guaranteed. Okay, and I wanted to do that for a long time, so now that's been done. I'm quite happy. Now getting back to those error strings, and so now I can safely calculate that number during startup, not have to worry about threads. Where is that? Strings. So now this is an example of a singleton. I don't know if you've heard of a singleton, but a singleton, I don't know if there's a strict definition, but it's basically a thing that you can be guaranteed and 100% sure will be alive and available whenever any attempt to use it is made, right? It doesn't even matter the order of things occurring during Initterm. By the way, I've structured this struct called syserr Initterm. It has no members, but it defines a static member, gnum codes. That's the one I want to figure out. And that there, since that's a static member, that value, this value, is going to be placed into here before any constructors of anything ever gets called. Okay, this is the static, not the read-only area, but part of the program image. This piece of memory is part of the program image, and this assignment occurs before any code gets started. That assignment is done by the operating system. So you can be 100% sure that either this value is 0 or I will have set it to something valid. Right? Now, since there's no possibility of other threads, the setting of this value, if it is done during startup, then it will be done safely. And if it is tried to access after startup, this value will be set because I've declared one here. It's a static, not that it matters, but well, I'm using this name surprise it. I've put enough collision there. I've declared one, a static object of this type, and in the constructor calls this getNumCodes simply to fill in this. So whenever any code runs, even if it's during the Initterm, right, and calls one of these things that tries to access this number, I might find that it's 0. This thing might not have been constructed yet, right? But that doesn't matter. I fill it in and pass back the correct number, and that's thread safe because there's only one thread at that point. Otherwise, eventually, this thing will get constructed, and it will fill it in, and by the time main gets called, that number will be there and ready and not needed to be accessed or changed. And so the accessing of this number is 100% thread safe, and now I can do this normally unthread safe thing with complete confidence at any point in my program. And it's a fixed value, it doesn't change, and all I'm doing is checking to make sure that the array bounds haven't been exceeded for this error and returning a different string. Okay. I know it sounds complicated. All I want to do is return a string, but it's very important for me anyway to make sure that I've got a way now to do this sort of thing in any scenario. There's a window of single threadness where code can be executed with this kind of code, one-off things, and not have to worry about multiple threads. And here now I don't have to worry about the size of the string, and I don't have to worry about the size of the array. Got that all saved, and this is really I think it's the safest of all ways to get those strings. There's no possibility of buffer overrun because I know that these strings are declared as a static array. So this doesn't get used until those strings have been filled in. Okay. So now that was just a matter of one function. But it's good that I got those. I've gone through and I've fixed up those things I wanted to fix up. Maybe I'll just stop here. There are a few more things I fixed up. Let me check the time. Well, maybe I can add one more. Let's see now. I fixed that. So that's all fine and good. And I'm going to list here. This is my backstage. Okay. So we did the backward steps have been done. All this has been done. Never have to do it again. So now what I need is something. This is actually where I started, and I haven't completely tested it yet. I haven't tested it at all. This is to do the percent bar. I thought a good way to do it would be to be able to pass a callback function into this read text file that would get called back every so often and say how much of the file has been read. That's all, and then continue reading, and that callback can return true or false, indicating whether or not to continue reading the file. And that can all be done in a very thread-safe way as well. It'll have to be because there will be two threads, one reading the file and one checking to see if it should quit. And so and trying to get the percentage. So there'll be a variable bytes read so far, and bytes remaining or something, and those can be guarded with a mutex or a critical section, either way. So now I started doing that, and that's in the file utils. Now that's where does that start? I better wait till the next one because this is a bit long. I'll just show you the declaration anyway. So it used to be just these two, and now I've added this defaulting to no, both of these defaulting to no, and I saw the default's fine, it still works normally with no callback, so that's good. Now this callback, I called it a load callback using integers. There you can see the definition. 2 ints, an int ref, and a p void. The 2 ints are amount read, and the second total amount expected, I guess. The reference is to be set by the person called back on. That tells the thing using this how many bytes to wait till the next callback, and a p void, an optional user provided parameter for the for the call, like we do with everything else. There's always a user provided bit that might contain a this pointer of some sort. Okay, so I'll go into that next time.